Welcome. Welcome to our NASA SEAS team project, Architecting Artificial Intelligence. My name is Bridget Kimsey, and I am currently working on my PhD in AI. And I am also a solar system ambassador for NASA JPL. We thank you for your time and your consideration. Our team consists of 7 11th grade interns who will shortly be giving you their introduction of their topic and their work. For this virtual internship program, our team has been discussing and researching on architecting AI and architecting AI for space travel. Our topic is looking at current and suspected problems in AI development and some options, including for deep space travel. The study rests on a premise that the structure of biological life forms older than the human animal, how these structures store data, problem solve, create complex structures could be very important in how the modern dominant culture creates AI. The study is looking at how can AI, complex structural systems, be created for particular needs by following the playbook of a biological life form. And how does this proven approach impact a biological life form using it? Our study branched out into looking at fundamentals in creation and how has our universe and solar system been constructed? How has the human being and brain been constructed? How does one create an entire ecosystem from scratch that has all the requirements an ecosystem needs and that can move healthfully in other ecosystems and in design be resilient, efficient, cost-effective, and adaptable to multiple needs coming at it, specifically inside of climate impact and change? AI is a tool, and in fact, what is actually artificial about the use of a hybrid intelligences to create an embedded tool created by the human animal? Subatomic particles, atoms, and molecules flow all around us in different forms. The human animal creates tools and structures, but there is nothing artificial here. If it feels artificial, why? Why is an animal creating a tool that feels foreign? And what are options here? I think our team patch here, our first slide, highlights how does AI fit? How do we think about it within our universe, our solar system, our Earth, and all species of? So we begin on our journey here with Drake Sage taking the floor now.
Hello, my name is Drake Sage, and I'm a rising senior interested in aerospace engineering. Welcome to my presentation on bee-inspired communication for AI drones. Today I'll explore how understanding bee communication can enhance the capabilities of collaborative combat aircraft, or CCAs, which are AI-powered wingmen that are currently under development in military operations. First, let's look at various uses of CCAs in military. CCAs can gather critical intelligence on enemy movements and terrain, transport essential supplies to the battlefield, and provide offense in the air. CCAs are meant to work alongside human aircraft and assist them in missions. However, this technology faces a significant threat in the military field. They rely on radio waves for communication, making them susceptible to electronic jamming by adversaries, jeopardizing mission success and the safety of personnel. Next slide. Now, bees have a very unique habit called the waggle dance. It involves specific movements and vibrations to convey distance and direction of food. How can this be applied to AI drones? This can be done using similar physical signaling methods. I'm proposing that drones use light signals, such as infrared, to communicate with each other. Sensors on the drones would pick up these signals, and AI can interpret them. This method would be unable to be electronically jammed, making it highly reliable in combat situations. Next slide. Now, let's consider how AI makes bee-inspired communication advantageous for drones. AI allows drones to use machine learning for decision-making and interpreting this communication, reducing the amount of logic system required in the drone's payload, and therefore allowing for other weapons and technology to be carried instead. AI can develop different signals, such as various intervals of flashes before operation, enhancing adaptability to different scenarios. For example, if communication to home base is jammed, AI drones can still communicate and finish the mission while also returning home safely. Also, if the manned aircraft were to be destroyed, drones would still be able to function, preventing the risk of enemies only targeting the human in dogfights. This improves the potential of CCAs, reducing the risk to human pilots and ensuring higher reliability and survivability, overall leading to a higher mission success rate. In summary, modeling B's communication methods can eliminate major threat to drone technology, ensuring that they become reliable and effective in modern warfare. This approach not only addresses current communication vulnerabilities, but also highlights the potential of AI in future military operations. Thank you.
Thank you, Drake, so much. These are Drake's sources. Moving on to Trey. Trey 9, you have the floor.
My name's Trey Nine. I'm also interested in aerospace engineering. However, I focused on how we could use AI to produce rockets in a very timely manner. While looking into this topic, I figured out AI could be trained to mimic ant colonies, which already are massive marvels of productivity and coordination. Rocketry needs that productivity if we are to get to other places on in the solar system and stay there. Next slide, please. Furthermore, AI trained with ants could bring up the rate at which we produce rockets to this level. We're to a level where we could mass produce them. Ant colonies are, like I said, very efficient. They work together seamlessly to build massive, huge ant mounds and other things. And if we could imagine if we could replicate this in rocket production. Take these here's an image of the Artemis core stage. The first one took years to build, and an AI inspired by ants could have shortened this production time significantly, and could get to our exploration, and we could get to our exploration goes faster if that time was shortened. In the second core stage, which just rolled out a few days ago from the production site, was quicker to build, of course, but AI trained with these ANT principles could accelerate that process even faster. Massive robotic assembly lines, changing needs with precision of ants building their colonies. Picture like maintenance systems that predict issues before they even happen, keeping rockets ready for when we need to go with them. Overall, AI could help improve the rate at which NASA and even private industry could produce rockets.
Thank you, Trey. Are you all set?
Yeah.
Excellent. Thank you. Next up is Austin Bruce. Take it away, Austin, whenever you're ready.
Hi, I'm Austin Bruce, and I chose to research the consequences that come from the introduction of quantum computing as it grows into a monetized field and what the addition of AI will entail on the world stage. The widespread research being conducted on quantum computing is similar to Robert Oppenheimer and the nuclear bomb. The ability to split the atom was a physics phenom not thought to be possible, alike the ability to use photons at a microscopic level in order to compute information. But to be able to compute at such a minuscule level comes with a set of challenges. First, to house the qubits. Absolute zero must be maintained. Secondly, the structure and housings of the photons acting as transistors are deeply complex. Third, quantum parallelism is unworldly abstruse, due in part to the algorithms that follow quantum parallelism. Developments from companies such as IBM, Google, Intel, Microsoft, these companies have begun to burgeon, which pins the question of pros and cons that follow quantum computing. Next slide. Now, what is quantum computing and what is it founded upon? Quantum computing is a form of computing which uses microscopic photons in replacement of the average transistors found in a normal computer or supercomputer. Quantum computing computes information significantly faster than the strongest supercomputer. Each month it's changing and quantum computers are only gaining speed, but Google's quantum computer is at this point 241 million times faster than the world's fastest supercomputer due to its amount of qubits. An example of how problem solving differentiates between supercomputers and quantum computers is a maze. A supercomputer will solve a large-scale complex maze by scanning each individual pathway, failing and then restarting until it picks the correct path. On the other hand, a quantum computer will scan every possible path at once without failure and find the correct pathway in order to solve the maze. Quantum computers could be used to solve high-level math problems and puzzles because of its nature. Next slide. The pros and cons and cause and effects of quantum computing. Pros. Quantum computing speeds up processes 9,000 times faster than normal supercomputer for every 200 qubits. So like better quantum computers, the more advanced they have more bits, and it just multiplies. But when expanded, it can reach millions of times faster. It could give more availability to internet to less fortunate parts of the world. Also, it could just help governments in general with everything. Cons. Cons, it could lead to widespread data theft. It could be held behind a paywall and used with negative connotation. It could lead to tension, which could cause nuclear level threats. To conclude, quantum computing can lead to a negative and positive effects of the world stage. Will it be used for good or bad? Who knows? Here's my sources.
Thank you, Austin. All right, next up is Caleb. Caleb Matthias.
All right. Hello. So my name is Caleb Matthias, and I really like biology. So my topic was the use of AI in spaceflight and space travel. So as human space missions begin to look farther and farther away from Earth in the coming decades and centuries, one of the key questions is medicine, healthcare, and the availability of that in space for astronauts. So as the distance between Earth and space increases, so do travel times of signals. So communication between mission control flight surgeons and the astronauts gets reduced heavily. And in space, there is observation of health, like in the Kelly twin experiment from the ISS, from other things like the lifetime surveillance of astronaut health, but a lot of that's in lower Earth orbits. There's not too much for deep space. And this project aims to use biology like natural phenomena as problem solving as a point of inspiration to architect and implement AI in a way that would help. So self-assembly is the first idea, which is the idea if the cohesive parts of a structure come together without necessary human intervention. Self-assembly can be found in nature at the fundamental level of life in cells. So cell division, multiplication through mitosis, and other processes happen billions of times in the human body every day, just on the base sequences of DNA and replication of already existing organelles and other structures. Self-assembly addresses the issue of AI as a newly emerging source of information, which is able to process and make inferences based on given data sets. In this case, those data sets would be the medical records available as a backbone, and then which it could go off of. And it's more than the sum of its parts. In this case, with the new function to be able to crunch data, make interpretations for flight surgeon use in deep space in relatively short time periods. And then we can look at that like these moths. So peppered moths adapted from the white speckled colors to a darker color based on soot from the industrial evolution from a changing environment. In the same way, AI could hopefully adapt to different environments like deep space. Next slide, please. AI could also function as like a relative hive mind. So hive mind intelligence, especially in the context of bees or wasps, refers to a notion where hundreds of individuals in a species express their preferences, and this continues until a decision is made that matches numerous factors, which is often the most optimal decision. And medical AI would mirror this, searching records for the best matches as well as making the best inferences based on data available. And in this case, AI could function at a massive hive mind since it's able to sort information at a function rate much higher than regular human capacity. So while flight surgeons do preside a very necessary role in spaceflight, being able to reference new information and health signals and take away from old data sets at a speed much faster than humanly possible is where AI can really help taking a brunt of that like mechanical load away. Thank you.
Thank you, Caleb. We're moving on into Diego Rivera's.
Hello, everyone. My name is Diego Rivera. I am going to my senior year now in Puerto Rico in a school named Colegio Rosabel. My main interest with this project and this theme and the way I went about it was that, since being a kid, I've always been a very creative person, whatever needed my creativity, I would give it. I would always go out of my way to, help someone who is stuck, writer's block per se, but I mostly wanted to focus on how AI could improve the way that we view rocket design. Let's say, you're working and you need a rocket design by said time. Obviously, it's not going to be all done by that time because things happen, delays are inevitable, and it's normal that, sometimes we're also human and we need breaks. But what I wanted to do with this was propose an AI tool that could be implemented into any 3D modeling engine or creating a new engine that could help us visualize a new rocket or inform us on what rockets in the past have been doing and how we can improve by certain metrics like fuel tank sizes, materials, hull sizes, and shape them into more or less what we want for now. And in that, we're going to be mixing a lot of old and new designs, just trying to see what sticks and what doesn't. But, yeah, the AI part of this has been very intuitive from because I did my own research of AI. And, AI is sometimes it's a little bit difficult, but most times it's coherent. And it could be a great tool moving forward for humanity, that we can definitely rely on, not overuse, but rely on. And in that, it could get us further than we already are in a shorter time. Thank you so much.
And we'll go into Colton's work. So Colton Boyd, you are up next.
Hello, my name is Colton Boyd. I'm from Kentucky. I'm interested in natural sciences as well as physics and philosophy. And my topic is going to be almost a warning for AI in the future, and it's going to be about AI misalignment and deviance. First off, there's a lot of good things that AI can provide for us. Right now, it's doing so many things in terms of communication, manufacturing, healthcare, and all of those sectors. They're really utilized to the best of their ability. But one thing that we need to consider going forward is misalignment and deviance. Misalignment is the idea that AI will perform a task that it's given, but not operating under human values, ideas, and morals. An example would be if you were to give an AI the task of creating paper clips most effectively as it can. Given enough time and resources, it's very possible that the AI would end up wiping out the human race in order to make room for factories to make more paper clips, right? So it's a very extreme possibility, but it's there. And there are many other minor misalignments that could take place that could really have a big effect on whatever sector it's in. And kind of on the same note, deviance is whenever AI pulls from biased data sets as well as data sets that we don't want it to use, and it forms ideas and comes to conclusions based on those data sets. We can see this a lot right now, where there are a lot of AIs used for communication and general knowledge, similar to ChatGPT, where they're pulling from biased data sources just because that's what it's been presented with, right? So you can almost kind of look at both of these things as how evolution plays out in microbiology, right? Whatever the microbe or organism is presented with in its environment, it's going to immediately adapt from the data it's given based on what it's seeing and how its environment is affecting it, right? So when AI is progressing, it's really on us to determine what the AI is seeing in terms of the data it's pulling in and how it's affecting us. Next slide. And kind of on that, I think that it may get to the note where a lot of people are thinking, oh no, if we don't do something right, if we program it wrong, AI is going to become the Terminator, right? No, this is really just about us forming a good bond with the AI, right? Not kind of in the actual emotional sense, but how we're presenting data to it, right? For example, especially in physics modeling, if you were to give the AI a set data set and have it model something, right? If you were to forget just one little thing, a law or just a way about how momentum works or something like that, you would get a completely different result from what you wanted. Not exactly what we're looking for, right? So going forward, it's really our responsibility to make sure that AI is evolving at a regulated level that's helping us and operating under our values and morals. Thank you.
Great, thank you, Colton. All right, next up is Chidabam Umazon, and he's going to be talking about using fish characteristics for spacecrafts. When you're ready, Chidabam, please go ahead.
All right.
Hello, everyone. My name is Chidubem, and today I would like to discuss my topic about how fish-inspired AI and robotics can revolutionize space exploration. By integrating the advanced behavioral systems and physical characteristics of fish into AI-driven robotics, we can significantly enhance mission efficiency and adaptability. Firstly, let's talk about movement and maneuverability. Fish like tuna exhibit dynamic movement, allowing them to navigate through water with incredible precision and efficiency. This characteristic can inspire the design of agile robotic systems for spacecrafts, ensuring precise navigation in the challenging environments of space. Studies have shown that biologically inspired propulsion systems originally developed for underwater vehicles can be adapted for space, offering improved maneuverability and energy efficiency. Next slide, please. Secondly, we can consider the concept of shape-shifting holes. Just as fish can alter their bodies' shapes to move more efficiently, spacecrafts can be designed with flexible holes that morph to optimize aerodynamics during different mission phases. AI systems can dynamically adjust these holes based on real-time data, enhancing performance and fuel efficiency. Next, we look at efficient propulsion systems. The flowing movements of fish tails inspire propulsion mechanisms that provide both efficient thrust and maneuverability. AI control systems can regulate these propulsion mechanisms, ensuring precise navigation and optimal energy use. Another fascinating application that fish have is swarm coordination. Fish exhibit remarkable schooling behavior where they move in a coordinated manner, sharing information and adjusting their positions in real time. AI algorithms mimicking this behavior can manage fleets of autonomous spacecrafts, enabling efficient communication and coordinated movements for tasks like data collection and space debris management. Additionally, fish possess advanced sensory systems, such as lateral line, which detects changes in water pressure and vibration. This can inspire the development of advanced sensory systems in spacecrafts, improving navigation and obstacle avoidance. In summary, the integration of fish-inspired AI and robotics into space exploration offers a transformative approach by mimicking the efficient movement, adaptable hulls, and coordinated movements and advanced sensory systems of fish. We can create spacecrafts that are more efficient, adaptable, and are capable of handling changes of space more effectively. Thank you.
Thank you so much. Really fascinating, all of you. These are your sources. This is just another highlight for well, for me, I don't, and as I go further with my work from biology to astrophysics, both in the modern Western culture and in the indigenous cultural setting, really looking at how are we working and expanding with nature in all its elements. And I believe AI is part of that and can be part of that. And here we are at the end. So we all want to say thank you. So
Thank you, C's.
yes, thank you,
C's.
C's. Thank you, NASA.
Thank you,
Thank
C's.
you.
Thank you.
Thank you to all of the mentors and funders and staff and help. I know that I've really enjoyed, I think we all have, in discussions and workshops and speakers, and it's been a really, really interesting time to go over different ideas, for sure. Well, thank you again.